Hello, everyone, and welcome to our today's series, Real World Architecture Antipatterns. I'm going to start right away. We're not going to be waiting for people to join, since the beginning of the presentation is vanity, general stuff, housekeeping, and so forth. So I guess even for the later arriving ones, it won't be a problem. The current session is part of the tech-savvy talks. They are organized by Scalefocus. Basically, let's do some housekeeping and the vanity part about myself in the beginning before we get into the actual content. The tech-savvy parts are, as I said, a format which started a while ago by Scalefocus, where our, let's say, rockstar developers, our lead engineers, and so forth, share some knowledge from their experience and also give lectures on some of the currently worth talking about topics in software engineering. Very grateful to be invited to the format and to have the opportunity to give a lecture as well. It's a very refreshing one. It's not a heavy kind of academic type of lectures that you get. So it's a little bit of everything. First, in order to compensate a little bit about the lack of possibility that we're still having kind of going out of the pandemic to be capable of doing lectures in person, we try to make the events a little bit more personal by some goodies that you can receive. You're going to receive the information after the actual event. There is cool stuff like beer and beer mugs. For some reason, especially in Scalefocus, there are many people who are very keen on beer. There's even a beer brewing club. So these guys won't send you anything cheap, and it's also a cool opportunity to have a free beer while you're listening to the next tech-savvy lecture. One comment about the actual format itself. Normally the sessions are organized where the lecturer speaks for about an hour, and at the end of it, everyone can ask questions. I decided to do this one a little bit different. So as you're going to see, we're going to be covering a few different examples which aren't necessarily connected between each other. So after each example, I'm going to switch to the Slido platform. On the right side on the screen, you can see how you can join. It's basically a 1-2 clicks thing. So as soon as you're there, you can start asking questions and posting. It doesn't even need to be a question. Basically, as soon as you see something that you think is worth commenting, is worth mentioning, you can post it there without having to wait until the end of the actual presentation. After each one of the examples, which are going to be just 3 of them, I'm reaching ahead a little bit, but anyway, I'm going to switch to the platform and check if there's anything that we can talk about. The content of the actual lecture is way under an hour, so we have enough time to make it a little bit more interactive this way. So feel free to join and feel free to ask. Now let's cover the vanity part. As I said, my name is Simeon Petkov. I'm the chief architect of Scalefocus. The background which might be relevant for this lecture is it goes in 2 directions, which I think are worth mentioning. I've been a developer for quite a while, and after that, I've been involved mostly in software architecture in all its different flavors, monoliths, microservice architectures, cloud native ones, event-based ones built around messaging systems, and so forth. And during this time, many anti-patterns appear, and I think I have something interesting to show there. The other part is that I have also been involved quite a lot in enterprise architecture, which is quite often a role which isn't necessarily filled by engineers or ex-developers. And there are some interesting things emerged as well. So basically, this combination of these two different backgrounds motivated me for the topic itself, which brings us to the topic. We'll be talking about patterns and anti-patterns, whereas I think I'm going to skip the part which covers what a pattern is and why you should use them and when you shouldn't use them, and that sometimes patterns tend to make you think in direction of the solution and not so much about the problem. So you're basically using the pattern to already propose a solution without having understood the problem. There is really lots of information out there on these topics, and I personally don't think that I can add anything new to it. It's been talked about by people a lot smarter than myself. There are lots of definitions out there, examples, and so forth. So basically, this entire topic of what patterns are, how they're used, how they can help us, and so forth. A, I take it for granted that almost everyone knows it already. And B, there is really enough information out there, so everyone can check it out. So why anti-patterns? Anti-patterns, at least in my opinion, are actually a very cheap topic. And very often when listening to lectures and also just having discussions, it doesn't necessarily need to be a lecture on its own. It's actually quite visible that it's very easy to criticize. When you are working on a system and you see that there is something wrong at a particular part of it, when you see an overall setup, in order to analyze it and criticize is extremely easy. And what I think what happens there, one of the things that happens is that there's a very hard disconnect between theory and practice when we speak about anti-patterns. So basically taking a real system which has been growing sometimes for decades, you have a multitude of teams that have worked on it, and that has some problems. All of them have that have evolved. And when you then apply theory to it and say, this is wrong, this is the way that it should be done. And if you do it in the way that, for example, consultants do it, it's very easy. It's very cheap to do it. So what I would like to do is kind of turn things around and go a little bit in a different direction and try to examine why these things actually happen. So not only identify something, say, this is wrong, this is the right way to do it, and then leave you with a bunch of boxes on a diagram which don't really solve a real world problem, but basically create some awareness and understand why constructs which are obviously wrong keep appearing, although all this information is out there and people know about it. So in a nutshell, on a very high level, this is what we are going to be covering today. In order to make it a little bit more concrete, instead of giving you an endless list of dozens of anti-patterns, I'm going to focus only on 3 examples. 2 out of them are going to be from enterprise architecture, and 1 is going to be from software architecture. Again, here, not to lose ourselves in definitions. What's the difference between enterprise architecture and software architecture? Very simply put, I would say software architecture is when you're examining one system and you're checking how it is, how it's built, what it's structured. This will have, just to make it more concrete, a database, maybe some backend parts, an API layer, maybe for governance, permissions, and stuff like this, and 1 or maybe various front ends. On the other hand, when we are speaking about enterprise architecture, we are looking at an entire organization. Let's say the system from the first example that we gave for software architecture is our ERP system, and that one needs to connect with a CRM system, with some billing system, with anything that you might imagine. And the way that these systems are interconnected, the way that they collaborate in order to fulfill one general process, which is eventually split over a multitude of systems, is what we then call enterprise architecture. It's generally not a very good idea to try to give examples out of the real world in order to describe software architecture, but anyway, I'm going to do it. A good analogy here, I would say, is that software architecture is a building. The way that it's built, the materials that have been used, how many stores it's have, and so forth. And enterprise architecture is city planning. How the buildings are connected by roads, how your public transport system works, how you supply them with electricity, water, and so forth. So, as I said, we're going to cover only 3 examples: 2 enterprise architecture, 1 software architecture. All of the examples aren't official examples. They don't really have names. That's things that I've seen, most of them various times throughout the years. So don't expect some textbook stuff here. It's all out of experience. On the other hand, for example, for the enterprise architecture part, in particular domains, I would go as far and pretty much guaranteeing that if you work in one of these particular domains in specific types of companies which are, let's say, very dependent on software, and chances are, if you're a developer or an architect, that at some point in your career you will end up working at least for a while in such a domain, I can pretty much guarantee that you will find these antipatterns there. So our idea here is to dissect why they exist and how and why they actually appear. What we gain out of this is creating some awareness that they're there, because they have side effects. There are things that need to be kept in mind when working in an environment where these antipatterns are present. And for some of them, as we're going to see, it's not going to be possible for all of the examples that we're going to see. We're going to provide a few countermeasures. Good. I think I was enough as an introduction. Let's just dive into the first one. Our first antipattern is going to be out of enterprise architecture, and the domain is banking. There's an asterisk at banking because banking here, I am focusing on old school big banks. We're not talking about fintech applications, virtual banks, and all the new breeds of fintech that's actually on the rise right now. We are talking about your classic bank that's been there for decades, the one with the big buildings that charge you on your account for things that you don't understand. I have worked in 6 of them, 2 in Western Europe, Austria and Germany, and 4 in Bulgaria. And I've seen this anti-pattern appear 5 times in all these 6 examples. In order to walk through it, I don't just want to present it. I would rather take you on a journey. First, what is a typical task in a project in such an organization? And as a second part, show the actual context where this task is being carried out. And the combination of both will lead us to the actual anti-pattern. So a very simple task, really very minimal background to it. There's really not much you have to know in order to understand it. Let's say there's an existing service. It might be anything, cashback service, whatever. You can make it up on your own. And our idea is, for example, to add a specific type of chargeback for a selected customer group. Generally, in the types of changes that are being done to such services are minimalistic as of logic. So you can do the actual change as of codes that will do the actual work. For example, as soon as you have gathered all the data for the specific customer groups, of what type they are, what were their last transactions, and so forth. As soon as you have gathered this information, the actual code that you need to write is simplistic. It's not really not even worth mentioning, but the preconditions that you normally have are a little bit complex, given the size of the organization. That also makes sense. So for the sake of simplicity, let's say we have 5 external interfaces to gather our data. Let's switch from the business example that we defined right here to the technological side. The situation looks like this. We're developing a simplistic service which basically acquires data from 5 different sources. One REST service your last transactions, another REST service, the type of customer that you are, a SOAP service, which is, let's say, from an older system, which, for example, can tell you what particular chargebacks you're already receiving, an MQ system where you need to send a message and receive a response in order to get some other meta information about your particular account, and a socket, for example, if the service needs to do some statistics on all the transactions that you have been doing throughout the years. Sounds simple. One thing that will happen here, reaching already ahead a little bit, is that you will notice that things happen very slow. So basically you would think, oh, if I had all the data available, I could have done this in 2 weeks, and 3-4 months have passed. You're speaking with consultants about different type of services, and everything starts going really slow. So in order to understand what's happening, let's have a look at the actual context and how this organization actually evolved throughout the years. So somewhere in the 90s, generally there was a mainframe, an AS400, something similar, and it was doing pretty much all the work. Front offices weren't really automated. There wasn't much going on there. Sometime later, in the 2000s, things started getting automated quite a lot. Systems were integrated with each other very primitively, file transfers, existing interfaces. Nobody was really thinking about that much. One particular system was supposed to do one particular job. And the 2010s, terms like service-oriented architectures, web services, enterprise service buses, messaging systems, and so forth start getting popular. A little bit of infrastructure as of the existing systems is already there. And we start developing services as standalone and on top of this infrastructure. Doesn't look all too bad still. And the 2020, microservices, some of the things get into the cloud and so forth. Again, we are implementing on top of this infrastructure. So this is what we have. And now we start implementing our service in this context. Our service is here, and the data that it starts acquiring comes from different layers from this architecture that has been growing throughout the years. Let's say this is one of our REST interfaces for a particular set of data that we need. One of our SOAP interface, this might be our socket, and say another REST service. So what happened here is we started, the organization started developing an architecture which is horizontal, which is supposed to feed other software components, which are then carried out as projects, which start consuming this architecture. So we did this once here. The pattern already starts appearing a little bit. Let's do it one more time, and maybe one more time. And I think you already start understanding what's happening here and what is going to happen if you do such project-based work on top of an architecture which is structured like this, not 3 times, but when you do it 30 times, 50, 100 times, which is not a lot. This is small changes to existing infrastructure. And I'm going to stop here. We can do a discussion and see if we have already some input coming in on this part of the presentation, to see if we can have it a little bit more interactive. I'm just going to give it like a minute or so on Slido to see if we have something coming in as questions. If not, yes, it looks like the slow death of the entire infrastructure. Yes, it's put a little bit harshly, but I agree. It is the case. I mean, you can imagine on your own, when you continue working like this, what's going to happen with the overall structure of everything, and especially how slow you will be able to make changes at some point, until you're so entangled in everything at some point that it simply won't be possible. It will be possible technologically, but basically nobody's going to pay for it from one particular point onwards. Anything else? Question: why are the old systems not being replaced, but only partially hidden between facades? Yeah, that's a very good question. So basically, when you look at this from the timeline point of view, you could have said, for example, so first you built your monoliths on top of the mainframe. At this particular point, it doesn't make sense. The mainframe holds the ledger normally in a bin. That's what it does mostly. It is a very big question for which I still don't have an answer. Why a system which basically holds a table with 2 columns? Of course, it's more complicated than that, but why does it have to cost double-digit millions? But that's what the ledger does. The monoliths do different stuff. They are front office and so forth, so they need to be there. Then you do integration stuff, and you don't integrate everything. And this is normally a budget question. Do we really need to integrate everything from the underlying system, which is extremely complex, given that most probably nobody is going to be interested in that data? Now, this topic about data in 2022, all of a sudden, everyone is interested in all of the historical data that you have for machine learning and all different kind of reasons. So things that you didn't anticipate in the beginning started appearing. So there are reasons why the systems haven't been replaced during the time. Of course, you have benefits, but it's just reality. It's not, probably in 2000 or when you were at the AI level, no one would have paid you to completely get rid of the mainframe and move everything one layer further up. But it's a very valid question. Good. Give it a few more seconds. I like it that we're getting interactive. That's exactly what it is. Yes, the big ball of mud is when you go on with concepts, let's call it concepts that look like this in the beginning, that's what you end up with. A system which is pretty much impossible to untangle. And at some particular point of time, it's actually easier to reverse engineer the business logic behind it and build it from scratch than to untangle everything that is thrown here. That's the beginning of it, so to say. Good, that was 3. Just minding the time. Slow and permanent architecture degradation or death of the system. It's pretty much the same. So my conclusions are pretty much the same as the ones that are coming from the audience, which is cool. Change in extension speed suffers permanently. I think this is maybe one of the most important points here. Back in the days, I would say we used to create specific architectures in order to facilitate specific features. That was a very typical thing. A request from an organization was, we need to be able to do this. This might be offer a mobile app, offer a new type of service like our competition, but our architecture isn't allowing it. We need to change the architecture in order to allow for this feature. The change of an architecture in an organization of a particular size might take years. So after these years have passed, the features that you're releasing are already outdated, and you start playing this cat and mouse game of adapting your architecture for the features that are being requested. Currently, I think it's a very good idea to try to create architectures which have one goal, that they can adapt fast to change without you knowing what the change is going to be. After enough application situations become, yeah, we covered this one as well. For here, I don't really have a compensation mechanism. So as soon as you're here, I really can't give very good advice as like do this and everything's going to be fine. And the reason for this is simply reality. There is not one particular reason that you could point out and say, this is why this happened. Good. Cheap alternatives comes with big debt. This is why architecture should be involved from project definition. Yes, exactly. I would even go one step further and say that architecture comes before your project, and then you already plan for change. And in this particular context, your current project is simply one change, one thing that you want to start doing that you haven't been doing before that. Yes, very good comment. Cheap alternatives come with big debt, and technical debt accumulates and it doesn't go away. Very true. Good. Let's dive into the second one. The second one is going to be extremely simple. It's an example out of software architecture. And the domain is, let's call it enterprise systems. Enterprise system basically doesn't mean anything. I'm just going to cover it in a second. The reason why I put this simplistic example in here is because in the last 12 months, I saw it 12 times, and I think it's extremely obvious why it's wrong. So what is a standard enterprise application? A friend of mine recently described it as an Excel sheet with parent-child relationships. Basically, all enterprises have such systems. You have your products, the relationships between them, maybe a bill of material, what categories they belong to, and so forth. Basically, a data maintenance system, a simple UI that basically does CRUD. And normally, and not normally, but let's say very often, these systems are only used internally. It means that don't have to scale. They're being used as, let's say, something like a back office application, so that a very separate part of your staff can maintain their own data. Very often, when an organization is confronted with the creation of such a system, there are no hard requirements on the technology. The most important thing usually is price. We need it simple, we need it fast, and it shouldn't be too expensive, because basically the system really doesn't do much. And one architecture which appeared a few, I forgot how much it was, 6 times or something like this in the last 12 months, looked like this. It's 2022, starting from bottom to top. We're going to do the front end in, let's say, React. We have an API manager lying around in the organization anyway. It's going to cover everything connected with authentication. We can do some governance. So basically, this one will come for free. Again, for the backend, monoliths are bad, so we're going to do microservices. But the data that we're using is actually highly relational. So basically, the example that I gave in the beginning, products, categories, bombs, stuff like this, heavy relationships. Basically, the relationships are the actual value of the data that you have. So we're going to put it in a relational database. And we end up with an architecture like this. So again, I'm going to refrain from giving my inputs to the whole thing. Let's check if we have some input on this one. What's wrong with this architecture? I'm going to give this one a minute because I really expect some inputs to be coming in here, because this is, I used this architecture. What's the problem with the microservices on top? Even if they don't really scale, they are modern and don't do harm. Okay, good. Let's start from the beginning. First, if scalability was an issue, we could go to microservices. First, the definition was we don't need scalability really. Like, of course, every system needs to scale to like a few hundred, a few thousand users, but that's not real scalability. We're not talking about 40 million registered users and hundreds of thousands of simultaneous requests. But my point here is, if such a system really needs to scale, let's even say we need scalability. This is a CRUD system. In other words, your microservices, basically what here is being called microservices, they actually aren't. They do nothing. They take data and they pass it on to the next layer, which is going to persist it. If it's a more sophisticated system, they will do some simple validation, which in terms of the modern processing power, I would say, again, is pretty much nothing. So if this system is going to suffer from something, that's going to be I/O, or in other words, the database. And this is the only thing that doesn't scale in this architecture, because we've created a funnel. Basically, these microservices, which actually are just services, because microservices, you have two reasons to do them. Either you want to scale them independently from one another. Let's say we want to scale the second, but not the first. And you want to have the possibility to move them, to take the whole thing, the whole container, whatever it is that you took. For example, here, let's say our microservices are some Spring Boot and Docker containers orchestrated by Kubernetes or something like this. Then you want to move the whole thing, and the database needs to be inside of it. And if you can't move it, then it's just a service. So basically, it doesn't scale. You add complexity which is unnecessary, which only makes it hard. And if you get to the point where you need to scale, then you create the funnel. But yeah, good. Why do you need microservices? Good question. For that particular thing, you don't. So that brings us to this part: is we would ask ourselves the question, why would someone implement such an architecture for such a request? I mean, I'm not a psychologist, so it's going to be a little bit of a guessing game. I think it's that, imagine you're a software engineer, which in 2022 is working on your 10th monolith with EJB3, if you're in the Java world or whatever. You've never worked on microservices, never done anything on the cloud. All of the guys that you know are working with the newer technologies and using them. And at some point you get confronted with this request, and your manager tells you you can pick the technologies on your own. How many out of 10 do you think aren't going to break and say, I'm going to do it with microservices just to see how they work? I've heard this explanation. I don't remember how many times, but out of these 6 systems, a few were just because of that. Like the answer was because everyone's doing it like this way, and we wanted to do it that way as well. My answer would be you don't, but every now and then you get this answer. It's fear of missing out or something like this, because I wanted to try it, because I'm fed up using this other thing, and I decided to try something different. Good. So I think we covered most of it. Yes, one important thing for some of the patterns, like microservices, I wouldn't call them pattern, but actually an architectural style or something like this. For some of them, you can cherry pick. You can really take a little bit, a small fragment out of it, and that works, and you can apply it, and this will make your system better. For others, you can't. And this is an example where you can't. You either do everything following the specific architectural style, or you don't do it at all, because you do more harm than good. Unnecessary complexity, we covered it. You don't need an orchestrator, you don't need containers, you don't need nothing here. Basically, a simple old school monolith, in my humble opinion, would be a much better solution for this particular problem. All positive effects of the entire pattern are not present. You're not scalable on a partial level. You can't scale one of the services because funnel and your database is stopping you, and you can't move it either, at least not in a simple manner, because you need to migrate the entire database as well. And in the worst case scenario, you create a funnel. Good. Anything else? This question: the microservices are all tenants of the same database. Yes, exactly. This is the architecture which appears 6 times in 12 months. Is shared database a bad practice in general? Yes, it is. The question is, why does it keep appearing so often, and why do so many people at least try to use it before getting on a review, or why do we still need to analyze systems? They are, definitely. I would say that they are. This is why this is part of a presentation which is called Antipatterns. I think you can use back practices and anti-patterns as interchangeable terms. So yes, definitely. The database of microservice funnel. Yes, yes, exactly. Good. Let's wait just 10 seconds if we have any more questions. The interactivity is working good. I like that. That's great. Good, great. So this brings us to our last example. This is again from enterprise architecture. So we switched from enterprise software architecture back to enterprise architecture again. The domain where I've seen this anti-pattern 5 out of 5 times. Again, I worked in 5 companies. It appeared everywhere in each one of them. Was energy trading. Again, we'll cover a use case. I think it will be very relevant to other domains as well. I would gamble on insurance and maybe others again, but I think when you see the process that we're going to cover, you can kind of do your own thinking in order to see, for example, if the domain that you're currently working on might be affected as well. So the pattern normally appears when there are two givens. One is, we'll first cover one aspect of it, which is the actual process which is being implemented. Now, in energy trading, in contrast to more, let's say, high frequency types of trading, like, for example, Forex or crypto, the trading process is heavier and generally also slower. So, for example, when a trader opens a trade, it first goes into risk management. This can be automated, it can be manual, it can be both. It will do, for example, it will check your actual profile as a trader, how risky you are. It will check the actual commodity that you're trading, historical things. Currently, many of the projects that we're involved in are based on machine learning algorithms that will actually put the probability of the success of this particular trade on it. And only after you pass it, you actually get your trade gets forwarded to the actual trade management system. It's your company-wide ETRM, where, for example, things like enrichment, other types of transformations and so forth happen. And then it goes to a platform adapter. Of course, you're not trading internally with your organization. You're trading on some particular platform which is external. And there is an adapter to it, which will transform data. It's normally the enrichment and the transformations here are very simple. They're on a different level. So, for example, in the trade management systems, you will do ID matching, cleaning lot types and stuff like this. The platform adapter will, fix everything up to particular decimal points, to date formatting and stuff like this. So we have multiple. What did we see until now? We have a process which spans multiple systems. These systems are already in place. They're there. We have a heterogeneous environment. Your platform adapter will probably be delivered from the actual platform. Your risk management system might be something that you bought, and your ETRM, your trade management system, might be something that you developed in-house. Interesting to know also, these types of organizations are quite often very siloed. That means this risk management systems actually is part of the risk management unit in the actual company. So you have different staff working on the particular systems, and they are supported by different parts of the engineering teams in the organization. So now one very typical solution for this problem, which in this particular case is 5 out of 5 in the companies that I've seen it, since ESBs and service-oriented architectures are very common in these organizations, I'm guessing one of the reasons is that energy trading, particularly, especially in Europe, exploded exactly at the same time when these technologies, ESBs, messaging, and so forth, were extremely popular. There were some changes in the actual legislation between the trading. Don't make me explain everything to you. I don't know the details, but a lot of systems were built around this time, and many of them are still there. They're still working. They're actually not performing bad, and they're still there. So one typical solution is to go completely event-based and completely stateless on the whole thing. So basically, all of the steps, as you can see them in the actual process, have a counterparty on the lower part of the screen, the way that they're being implemented. You have a queue which receives a message, gives it to the actual processing part. As soon as the processing is done, it's being put on the response queue. This is the risk management part. The same thing happens for trade management. Here you can see the 2 wheels, so we can even scale this. We can scale up our workers on a particular queue. So if the load on trading on ETRM is higher than on risk management, you are quite elastic here. Based on the completely stateless event-based structure that we've created, we can do stuff like this. And this whole thing will work. Technologically, it's going to be brilliant, stateless, easy to maintain, you utilized systems which are already present anyway, and it just works from the technological point of view. Now, what happens a few months after you deploy a solution like this, which doesn't have anything else to it, is that the phones start ringing because, for example, a trade that was entered doesn't appear in the trading system, but there are no error messages anywhere. It seems forwarded, but you don't get actual feedback what's happening. And your typical scenario is that you have a trader which starts a complaint that a trade wasn't executed. So he kind of knows that the first step is risk management. So he gets in touch with support representative from the risk management unit, and they start checking their system, which takes a few hours to open a ticket until someone actually checks everything. So sometime on the next day, you receive a response that, no, your trade was approved and it was forwarded. It must be somewhere else. A few days later, you understand that the next part is trade management. You check there as well, and they say, no, it was enriched, it was forwarded. And I guess you see what I'm getting. At some point, you find the system where someone explains to you that, yeah, you know, that field is now mandatory, and in your particular trade, it seems to have been optional because you missed it out. That's why we dropped it. For example, this happens on the platform adapter. And your architecture, although it's working technologically, it's not working in the actual environment. And the reason is that the context between the actual process, which is part of the domain, which is represented in the upper part, gets completely lost as soon as you use a stateless messaging event-driven system, which basically forgets about the actual context. It doesn't know which is the next step of the whole thing, and it completely destroys it. There are some simple, in that particular case, there is a very simple solution, which was also the places where we implemented it was solving the problem pretty much immediately. But I'd like to see some input or maybe some recommendations, some ideas. How can we solve this problem? Basically, we have a process and we solved it through a completely stateless messaging based system. And now we lost the context. What can we do in order to get it back and to solve this problem, that when something goes wrong, that we understand immediately, that we get a notification that something went wrong, and that we don't have to call all the particular support units out of the siloed organization. Let's see if we get some input here. Good. I shouldn't have shown. I should have shown this in the first place. So someone is asking if we can use the CID, which is short for correlation ID, in different ways. So good. That's my bad. So I'm good. I'm just gonna explain one particular solution. Since I kind of took the mystery out of it already by showing the slide. The solutions are correlation IDs and logging, basically extremely simplistic. By adding a correlation ID as part of the messaging system on top, you can recreate the context. I think it's quite visual, even when you see that the actual messages are between the systems and they start piping the correlation ID for the particular instance of this process from one system to another. The only thing that needs to be done there in order to recreate the context is to actually log it. And then you can use whatever system that you have at hand, which you will have at hand 100%, in order to recreate it visually or to put some alerting on top of it. You can actually have it visually represented by using something like a simple extension to Grafana or to whatever your favorite or whatever the present reporting framework for the particular company is, in order to use the actual correlation IDs, recreate the process which has been destroyed by by mapping everything to a completely stateless system, and then use it to turn the process around. So you don't have to start examining heterogeneous systems in the organization in order to understand what happened to one particular step in the process in one particular system, but you can reverse it and actually use the now correlation ID minding monitoring system in order to reverse engineer it. Good. Let's get back to the question, because I only saw that someone had seen correlation ID. Can this be done in the unintrusive manner without changing existing system, only by using options? That's a great question. That's actually one of the discussions which are actually done in the beginning when designing the actual solution architecture for this part. And the answer is sometimes. Sometimes you can, sometimes you can't. For example, if the system, some of the systems allow for this. For example, the ones that are messaging based normally allow you to put parameters into the envelope of the message, which are then being passed through to the next point, which is brilliant, which is exactly what you need. So you can pass through your correlation ID. Some are more monolithic old school systems, which work on file-based exchanges, only accept a particular list of identifiers and values and give you the same thing back after a calculation or something like this. There you can't. There you need to be intrusive, or you need to put something in front. This is like the less intrusive way, which in turn is then going to be stateful, because it needs to have a list, like for this instance of the process, I generated this ID and so forth. So the answer is sometimes, but it's a very good question, because this is the first problem that you run in when you start implementing this solution. Very good question. Good. Anything else? Is an event lock being used? Well, yes. Basically, if you do use an event lock here, you would solve this problem from the beginning on. But the point is that for, let's say, the more old school systems, like ESB-based messaging systems, which are not really aware of the pattern of an event lock, which can basically describe the state of a particular system at a particular moment in time, but they basically just work on a set of messages that they have received. You have to basically introduce this kind of event lock based system in order to recreate the process. So yes, you can. Obviously, when the problem appeared, it wasn't used. If you apply one, it's a very good solution to this problem. Yeah. Good. The system structure reminds me of Conway's law. Oh, good, Conway's law. Good for the ones that are not familiar with it. Oh man, I can't say it by heart, but basically it says, yeah, that's a good one. Yeah, it says that whenever an organization builds a software system, the structure of the system that they built will be an exact representation of the communication channels as they exist in reality in the actual organization. So basically, kind of you're doing something like a representation of the structures that you already have present in the organization in the software systems themselves. I think if we go back, you can actually see it, how, for example, in many of the energy trading units of utility companies, there will be a unit called risk management, and the systems are called exactly in the same way. You have a trading department, you have at least a part of the support that is engaged with supporting a particular platform. It might even be a part of a unit. So as you might see here, if you draw it that way, the way that the diagram is given here, you can see that parts of your architecture actually represent the actual communication channels as you have them in the real organization. So how trading needs to first consult with risk management before actually posting a trade. I'm guessing I haven't been involved in energy trading before the existence of ETRMs, but I'm guessing this is how it worked before the systems were actually there. So yes, that's actually a very good point. And I think it's interesting, especially in this context, that you actually need to mind the process, because the process kind of is a representation of the communication channel. Because if you only look at the ESB and the messaging destinations that you have present in an organization, you couldn't reverse engineer the structure. But if you look at this, if you look at the whole picture, like we've drawn it here, yeah, definitely you can actually see it. It kind of proves it. That was a good one. Good. Anything else? No. Good. So there was our final example. Let's see what we covered with the discussion. Yeah, I mean, I kind of reached ahead already by presenting the actual example. Purely event-based systems can destroy context. They're great. Every time that you can do something in a stateless manner, you should. They can solve a lot of problems, but in many occasions, context get lost, and you need a way to recreate it. In many situations, you do. This domain process, which actually lies behind this, let's say, chain of events that are going to be triggered and operations that are going to be triggered by the events themselves, they represent a structured process, and that recreating it solves a lot of actual domain problems. The solution that I presented is a cheap one, is a fast one. I guess we can do a dedicated, a lot more technical, targeted lecture only on how to solve this problem in messaging-based systems. But this is one of them. It's very simple. It works. I personally have been involved in quite a few solutions which have involved in it. It's extremely effective. A very good point here is it creates a foundation for more sophisticated data analytics solutions. If you think about it, currently data is becoming more and more interesting, and the more data is connected, the more value it has. Basically, having to reverse engineer these connections between the actual data units as you have them in this heterogeneous environment currently is very hard. The introduction of something extremely simple like a correlation ID solves this problem. You actually populate the data with the connections present, and you don't have to reverse engineer them. And the guys in the machine learning department will be very grateful to you. Actually, you don't even have to go full-featured machine learning. Anything connected with more advanced reporting, business and BI and so forth, they will benefit straight away. What's the reason that this anti-pattern appears is a strong disconnect between business and technology. It's something which you will see very often, especially in siloed organizations, and problems being there for this reason are still there. I can pretty much guarantee that you will find plenty of them in this type of enterprise architectures. And yeah, that's one of them. Good. Yeah, Dilbert normally has all the solutions to all the problems. One of them is, I think this was one of the first comments that we had, is that cheap solutions accumulate a lot of debt. I'm not sure if I'm citing it right, but yes, sometimes the things that accumulate debt in software architecture are very hard to explain, especially to management. And if they are not taken care of at the right point in time, the cost that needs to be paid sometime after they have simply been there doing nothing and that have been utilized the way that they were supposed to be utilized, all of a sudden becomes very, very expensive.